let's see here. This was miles. This was inches. And the given point you have here is that 79 miles is 5 inches. So yeah, this is not really drawn to scale. Maybe I had to go a little more vertical with it, but you could throw that point on there, 5,79 if you wanted.
Yeah.
Part C is the using of the equation. So once you have the equation, you'd like to use it. So we'll do that here. We'll estimate how far Waco is from Austin if they are 6.5 inches apart on a map. Again, we have y equals 79 over 5 times x. You have to decide if they're giving you x or if they're giving you y. Because it's in inches, they're giving you x.
Right.
So you have to convert that to a fraction, 13 over 2. Y equals 79 over 5 times 13 over 2. The only sort of nice thing here is that the bottom is 10. So that divides nicely, but you're going to have to multiply 79 by 13 there. You're welcome to use a calculator, do it by hand, whatever you're allowed to use in class.
All right. Let me just calculate that real quick. So unless I messed up, that's 307 over 10.
79 times 13. You're off by like 790. Remember, you got to multiply. The 3 times 79 sounds like 307. No.
I got 307.
For the whole thing?
79 times 13.
Yes. So it's got to be at least 790 because you're multiplying by 10. Are you doing it this way like I'm showing, or are you just
yeah.
Okay, so 3 times 9 is 27, 7 carry of 2, 3 times 7 is 21 plus the 2 is 23, and then you bring a 0 over for the carry of the into the tens place, and then it's 1 times 9, 1 times 7.
Oh yeah, okay. I just didn't.
That's okay. You won't be asked to do 2-digit by 2-digit multiplication very often. Since it's divisible by 10 or divided by 10, that's just moving the decimal place. That is 102.7 miles.
All right. All right. Oh, I did 12. I got, hello?
All right, you said you did this one? Sorry, I just want to make sure I heard you right. Okay.
I got 13 bananas and 12 apples.
Okay. Have you ever bought bananas or apples?
I guess at the grocery store, yeah.
These prices are not correct. Bananas are pretty cheap, but apples are not. All right, so you said 13 and 12 or 13 and something else?
No, 13 and 22.
22. Okay, that makes more sense. So that part's correct. 13 times 10 is $1.30, and then 22 times 0.25. So the way I do it, I know that 20 times 0.25 is 5 plus the 50 cents from the extra 2, which is 680. Good. Really good. Yeah, we can always skip some if you feel like you got it. On to another multi-step for 13. So let's take a look here. I got to snip this in pieces. All right, find the area of the smaller square. So to me, the smaller square is the one that has the edges with x and x in it.
Mhm.
So the area of that one is x squared. So I think we've got that one down. Now we'll get to part B, but we do need to find the area of the larger one. And I think the thing that might be, forgotten here is that you have to add 5 to both sides. So it's x plus 5 plus 5.
Oh,
And then similarly, x plus 5 plus 5. So it's really x plus 10 and x plus 10.
Mhm.
And then the area you find, calculate by multiplying those together. X plus 10 times x plus 10. So will you FOIL that for us? We are going to use that in part B.
Mhm. Okay,
Oh, actually, that is part B. So
yeah,
you got it going. Oh, and C is the simplified. So when you FOIL this, you will have part C.
cool. First, outer, inner, last. Okay. Is it x squared plus 10x plus 10x plus 100?
So you can combine the outer and the inner, the O and the I.
Yeah.
Awesome.
So B was just asking for the expression, basically.
Equation.
Yeah.
They want to just sort of set it up and then give it actually calculate in part C. Part D here, I will actually snip something in here. Not that though. D is to write an expression for the shaded region. And it's a composition of things. It's the larger minus the smaller.
Mhm.
So it's going to be that x squared plus 20x plus 100 minus the smaller, which is just x squared.
Yeah.
And you can see those cancel. So
it's
the,
meaning x plus 100.
yeah.
All right, that makes sense.
Okay. Generalize. All right. Generalize. Use examples to explain why square root of x squared equals negative x for all values of x.
This example to explain why. Root of x squared. So is it saying that if
They're saying to build a table here where you have you start with negative x values. So like, for example, assume x is -1 and then do the square root of x squared.
Mhm.
So that in this case, you would square first. So when you square a negative, it becomes positive. The square root of the number becomes 1. And then they're asking, is that the same as negative x, -1? You can see that it works. But you have to choose negative values of x. So like for example, how about -3? So it's -3 squared, square rooted.
So no.
Becomes 3. So okay, just to be clear here, it's the second 2 columns that have to be the same. So yeah, the 1 and the 1 are the same.
Yeah.
And then is -3 equal to 3?
Yes.
Yes. Okay, so you pick any -5. Actually, let me pick 6 because I don't want you to think it's even or something. You take the square root of parentheses -6 squared. So -6 squared is 36. Square root of 36 is 6. And then is that the same as -6?
Yeah.
Yeah, so I think they're looking for you to say in words that this works.
Uh-huh.
And I think, maybe just having a table is sufficient.
Yeah, probably. Let me just. All right. I'm good.
All right, so you ready to go on to 16?
Yeah.
All right. Or
Or
15. Did I
15.
miss one? Dang,
15.
I keep doing that. All right. Yeah, there's a reason I did that. It probably is something like, man, I really don't want to have to do this problem. Sometimes you just do that. And you all right. Remember, for systems of linear equations, you can use substitution, elimination. There are other methods. Those are the primary ones. To use substitution, you hope that it's already solved for a variable like X or Y or close to it, and neither of these are.
Yeah.
Elimination's your better choice here. I am drawn to the fact that it's plus 15 minus 3y.
Mm-hmm.
And that's where I would say, okay, that's where we're going to start, because that tells you which variable you're going to eliminate.
Uh-huh.
So if you believe me here, we're gonna multiply the second equation by 5, because that will get you to minus 15 to go with the positive 15. That's 35x minus 15y equals minus 15. And then you bring down the other equation, 6x plus 15y equals 15. You go ahead and add them together. When you add them together, one of the variables should cancel. In this case, the y's cancel. You get 41x equals 0. It's okay to have 0 on the right. Maybe it doesn't look right, doesn't kind of work the way you want, but it is okay.
Uh-huh.
What is the value of x in this case?
0.
It is 0. That's okay.
Yeah.
Okay, so now you can use either equation to find y,
Right.
your choice.
Yeah, we can just go with the second one.
Okay, so I'll let you do that. 7 times 0 minus 3 times y equals minus 3. Let's see if you can solve that for y, please.
So y is just 1.
Yes. And if you really wanted to, you could check it in the other equation to see if it
Yeah.
worked.
No worries.
It does work. Right. Right. Jamal and his friends want to rent a limousine for prom night. The cost per person varies inversely with the number of people renting. So that inversely is very important there. We did a direct variation earlier. Renting limousine. If 4 people rent the limousine, it will be cost them 180 each. How much would it cost per person if 12 people rented the limousine? I think limousines aren't really popular or anymore. I don't know that I've seen one in a long time. Kind of interesting. Used to be really a big deal to get that. So y equals k over x for inverse. The direct is k times x.
720 for what, k?
So are you making x people or money or both? Which way did you see it here? Like what is y? Was y represent the cost or the people?
Uh,
I read it, I do it in order. So I like whatever it starts with, in this case, cost.
for the people is the,
Yeah. And if you're not using those those like C and P or those letters, then it's good to at least indicate that. So I wasn't saying you're wrong. I mean, it's $180, K over X, K over 4. So K is 720. We rewrite that. So it's Y equals 720 over X. And then if 12 people are in there, it's only $60.
right.
It's prom season, if you haven't noticed. Everyone
Yeah,
seems to be
brother
having.
just the other
Oh,
day.
nice, nice. All right, different lines are parallel or perpendicular. Okay, do you remember anything about how you determine if lines are parallel? Start with that one.
So if they're parallel, they'd have the same slope.
Yeah, good. So what you have to decide is, it could be, so in this case, it's one or the other. So if you decide that they are parallel, you're done. But if they're not parallel, then they must be perpendicular. The best way to do it is have them both be in mx plus b form.
Mhm.
The first one already is, so you can tell the slope.
Yeah, the second one we have to.
Second one, you have to move the minus 2/3 to the other side of the equation. And this is now M2. Are those the same?
No.
They're not. So we know they're not parallel. The reason they are perpendicular is they are opposite reciprocals.
Yeah.
But the better answer is that the product is -1. And you might wonder, why is that better? Well, if you take more math, you'll learn the real reason about perpendicular and parallel. There's nothing to do with slopes.
Yeah.
But it's a little beyond this course.
Right. So they're perpendicular. Okay.
They are perpendicular, yes.
All right.
All right, are we on to 18 now?
Yeah.
Oh, this has got a calculator icon. We're going to be able to do this.
Um,
I'm kidding. We can do it. I just, just making sure, just mentioned that before. Sometimes it wasn't.
oh, it's got a. It looks weird. It looks weird from the photo, but it's a graph. Like it's an icon of a graph.
Oh, okay. All right. Rachel will receive an A in her math for the semester if the mean of her test scores is at least 90. The first two test scores are as shown in the table. Write an inequality for the score Rachel needs on her third test to receive an A for the semester. Okay. So a couple of things here. The mean is the average. Let's call the last test score X. How would you find the average of these three test scores?
Adding them and dividing them.
So you add them all up, 85 plus 95 plus X, and
Yeah.
you divide by 3 because you have 3 test scores. And what do we want this to be at least?
At least 90.
Yeah. All right, so this is like the start of it. You have to get X by itself. But you have to remember that at least is greater than it's greater than or equal to. The numerator has implied parentheses. So you know, in terms of like solving for X, you want to undo this division by 3 first. How do you undo that?
We want to undo the division by 3.
Yes, you want to undo that first.
You multiply it by 3.
Yes. Both sides. Does that change the inequality direction?
Yeah, no.
The only time it changes is if you multiply or divide by a negative.
So no.
So no, it's good as is. what can you do on the left side here?
You can add 85 and 95.
Yes, so that is 180.
Right.
And then what's the last thing to do here to solve for X?
Take 180 or
Subtract.
Yeah.
Because it's currently being added. It's really positive 180. We just don't show it. So X is greater than or equal to 290.
All right.
All right. Any thoughts on that? It might even be something you've done. You know, what grade do I need on the final to bring my math grade up? Have you, when you submit this assignment and get kind of all caught up, do you know where you'll be grade wise in the class?
Well, I don't know exactly because right now, since it's on the school is almost over, they're grading a bunch of things, so I'll have to wait and see.
Okay. All right, so here's a new problem, X plus 5 greater than 3, and X minus 6 is less than or equal to minus 8. So do you feel comfortable trying to solve these each separately for me?
Oh yeah, just give me 1 second.
Yep,
I'll
take your time.
be right back.
Yep, let me know when you're ready.
All right, sorry. All right, let me start on those.
Yeah, give them a try. Let me know what you come up with, and then we'll do the graphing together.
All right. So the first one is X is greater than -2.
Good.
And the second one is X is less than or equal to -2.
Okay, now this is, of course, Saxon does it weird. Notice they're at the same place, -2 and -2. So for the first one, there's an open circle at -2, and it's everything to the right.
Mhm.
For the one on the right, it's a closed circle at -2 and everything to the left. Okay, so my question to you is there an overlap? And specifically, it's at -2. Is there an overlap at -2?
No, because that one doesn't include -2.
So there is no solution to this. There is no place where this happens. And we see this happen in real life. It's like you say, I'm free after 4. And I say, oh, I'm only free until 4. It's like, well, we can't do it today.
Yeah.
But in math class, we always wanted to kind of work out. All right, number 20.
Yeah.
All right, which graph represents the solution to X plus 6 greater than or equal to 2X minus 12? Okay. Now, normally you always move the variable left, and that does work here. That's a good option. Kind of with my experience, I prefer to move the variable so that I'm not making it negative. But that is my preference, okay? And you have to tell me right here from the start whether you want to do what I just proposed. And it doesn't matter to me. We're going to do it the way you want, or if you want to move the variable left. Which way do you see it?
I mean, we can just move I mean, that's what I would have done, move the variable.
To the left.
Yeah.
Okay. All right. So this becomes on the left negative x plus 6 greater than or equal to negative 12. What would you do next to solve this?
Wait, since you're subtracting negative 2x from that side,
Yes.
like
So think of it as
up into the negative.
so you have $1 and you owe someone $2. You now owe them $1.
Oh, okay, now I see. Yeah. Okay, so then you subtract 6 from both sides.
Yes. So you have negative x greater than or equal to negative 18. Now, we cannot say we're done until x is by itself, no negative in front.
Mhm.
How do you undo that negative in front?
Multiply it by positive x.
Negative 1, negative 1.
Okay.
Either multiply or divide by the number in front. What does that do to the inequality?
It flips it.
Flips it. Whenever you multiply or divide by a negative, it flips.
All right.
If you've solved it correctly, and that is important, make sure this is done correctly, you just go and match it up to the graph. If you haven't solved it correctly, then there's a bit of mystery, like whether it will be there or not.
Okay.
So it looks like it's graph B.
Mhm.
All right, 21.
No, well, we'll have to go up to 20. Let me
Okay.
do one more picture.
Sure.
Give me a minute here.
You're not into doing that extra rep in your math class right now.
No, not really. Yeah. All right, I sent it now.
Okay, take a look. All right, there it is. Okay, so you sent several pages and that's fine.
I sent two. The other
Oh,
ones are
okay.
the other ones are the other ones. We don't have to get through all of them though.
All right. Just start at one, or do you want
I did the first 7.
okay, do I need to check any of those or just move on to 8?
Um. Yeah, we can do 8.
Okay. It's good. I like hearing that you're doing some on your own.
Yeah.
All right. How do you know if a point is a solution to a system of equations? And the answer is that the ordered pair or the point, we use the word satisfies, you could say works, satisfies both equations. And what that means is when you substitute x and y, it gives you the right hand side. We saw that in a system we solved earlier.
Okay, we can do that.
Okay. All right. Number 9. What's interesting about number 9 is that you could try to use the solutions. Like if this were SAT prep, which is something I do help with, and you were like not sure how to proceed, you can always check the answers. Not always a great strategy. Usually better to solve it, but some differences here. So if we were to solve it, which variable would you want to eliminate? X or Y?
Probably.
And then what you should look for is, does one of the coefficients go into another?
Yeah, I'd say Y.
So you're saying that 6 goes into 9?
Well, no, like 4 goes into 8. Right?
Yeah, and that's what I was looking for you to see, because while you could multiply both equations to get rid of the y, you can just multiply the first equation by -2 to get rid of the x.
Oh, okay.
And that's what you're looking for, is something where you only have to multiply one equation rather than more than one.
Mhm.
So this leaves us with -12y equals -84. And now you can divide both sides by -12. And you'll find that y equals a value that isn't on there. So did I not add this correctly? Oh, no, it is there. Is it? Yeah, it is. It is. I'm sorry.
Yeah.
It does work. And that's in a good multiple choice, you probably would have to still find x.
Yeah,
But in this one, you don't have to, because there's only one that has the y value. That's the nice thing about standardized tests, is you don't have to show your work. You just have to get the right answer, but there is some work to do sometimes to do that. Number 10. 10 here, I'm going to snip this in. All right, the sum of two numbers is 64. Their difference is 14. Find each of the numbers. So the sum, x plus y,
Mhm.
is 64. Their difference, x minus y, is 14.
Yeah, I think I started this one like x plus 64 minus x equals 14.
I would just add the equations right here, because you're going to see that y is eliminated by adding them together, and that's what you really want. You want to get it down to one variable.
So we can eliminate the y, right?
That's right. You add them up vertically. X plus x is 2x.
Mhm. And then just 15.
equals 78.
Oh,
You're
we're
adding, yeah.
I was thinking about eliminating the y, so. Okay,
So X is 39. That's the first number. You have to find the second number. You go back to either equation to do that.
and just do either one, the first one, sure.
Sure. So 39 plus Y equals 64.
Mhm. Um. 25.
Yes. So those are your two numbers.
Right.
All right. So moving on to number 11.
Mhm.
All right, students were asked to find the product of 2b squared parentheses b cubed plus 4. Which student is correct? So what I really recommend is doing the calculation here, and that starts by writing it correctly. B cubed plus 4. You're going to distribute this to both. So I'd like you to try that, and then we'll look at their answers and see where they went wrong. But it's better to kind of do it clean slate without being influenced by.
Okay. 2 plus 4. So is it still like just 2b like to the fifth
Yes, you add the exponents. Good.
squared?
And then what's the second one?
8b squared?
8b squared. Good. Yeah. All right. So now when we look at the student A, student B, we can make a decision about that. So first you look to see, well, do either of them look correct? So A is correct. And
Mhm.
now we kind of can figure out what did student B do? Looked like student B, it's right here. They multiplied the exponents instead of adding.
Mhm.
Although, this is what the teacher just does. They just do that. And maybe you can just, put that in there for your explanation. Say, well, that's what you guys do. That's
Uh-huh.
all right.
Okay.
Number 12. Number 12.
Yeah.
All right. The length of a rectangular pool is 4 times the width. So they're giving you the length here. The length is X, and they're multiplying it by 4 to get 4X. A 4-foot wide pool deck surrounds the pool. Write a polynomial expression for the area of the pool and the deck. Use the distributive property to write your answer in standard form. Okay, so we want the area of the outside rectangle. So the X here, it's extended both vertically in both directions by 4. So the length there is X plus 8. We did the problem like that a little while ago.
Mhm.
On the other direction, it's 4X plus you've got 4 in both directions again. 4 horizontally. So that becomes 4X plus 8. And now you have to multiply them together. The area of the pool is X plus 8 times 4X plus 8. You can switch the order if you want, if you prefer, 4x plus 8 in front, then x plus 8. But I'd like you to try foiling this for us, please.
First order inner and black. Okay. 4x squared plus 8x
Good.
plus 32x plus 64.
All right. And then last thing is to combine like terms, those the outer and the inner.
Yeah. Oops.
Okay, on to 13, multi-step.
Yeah.
Henry is a game that includes a number cube. The side length of the cube is 5x plus 1 inches. Probably good to just draw something real quick to visualize here, but each side is 5x plus 1, 5x plus 1, 5x plus 1. Find the volume of the number cube. So to do this, you have to find the area of one base, like this front face right here, call that the base. That's 5x plus 1 times 5x plus 1.
Mhm.
So this is another FOIL problem. This is 25x squared plus 5x plus 5x plus 1, 25x squared plus 10x plus 1. Okay, but that's just part A. Part A is to find the area of the base. So we've done that. B is the hard part. B is finding the volume. The volume is the area of the base, which you just found, the 25x squared plus 10x plus 1, and then you're going to multiply it by the height. So I'm actually going to slide this over. I believe it's slightly easier if you do it this way, like this. So it's kind of a FOIL problem. You have to take that 5x and multiply it by everything in here. And then similarly, you take the 1 and you multiply it by everything in there. So will you attempt to do that for us, please?
Uh-huh. Okay. 125x squared. X squared plus x plus 5. Then we just add,
Any like terms?
well,
So you should have an x cubed term. Then you should have a x squared term and an x term. So there's a constant, a constant, a constant, and then a number here. When you're all done, when you combine everything.
it's the x squared plus 155 squared 16x plus 6. Okay, so I got 155x squared plus 60x plus 6.
Okay, yeah, then maybe this is a little too much here to ask you to do. Sure, it's just a small little thing. So let's go ahead and do these together. 5x times 25x squared. So that kind of first one there, that's 125x cubed.
Right.
And then 5x times 10x is 50x squared. And then 5x times the 1 is 5x.
So,
Then you have to do the same thing with the 1.
oh, okay.
So that's so it's
Yeah, okay. I was just multiplying by 5 instead of by 5x.
okay. And that will do it. So it's you can see here there's going to be some lining up of terms, not all of them, but some.
Like 5x and 10x and 25x cubed or squared.
Yeah, so it's 125 x cubed, 75x squared, 15x plus 10, like that. Except, I'm sorry, I multiplied wrong. It's 1 times 1. It's just 1. This is 1. And then this is 1. Okay, not all questions are created equal.
Yeah.
Sometimes they're really long. 14. That's why you may find it's not necessarily in your best interest to do all the ones in order. Just do the ones that you maybe do the shorter ones first. But let's see here. Number 14, measurement. Let me grab a snip of this. Let's see. Come on. All right, Tim has a garden in the shape of a right triangle. The triangle has a base of 6x squared plus 8x plus 12. Not to scale, but it might be better to draw something a little more like what we think a triangle looks like. And then the height is x minus 1. It wants the area of the garden. So the area of a triangle is base times height divided by 2.
Mhm.
Your base is the 6x squared plus 8x plus 12 times the height x minus 1, all divided by 2. So you get another chance here to work on this multiplication stuff. Probably better to reorder it so that it's x minus 1 times 6x squared plus 8x plus 12. Will you multiply that out for us, please?
Mhm. Okay. Am I just multiplying by the x and then the -1? Right?
Yes, exactly. Just like we did in the last problem, you'll combine a couple of terms.
Okay. Okay, so So 6x cubed plus 8x squared.
It's not 8x squared, but keep going. Maybe there's a smaller. What's the next one?
12x.
Okay. All right. So let me go run through this here. Yeah. So x times 6x squared is 6x cubed.
Right.
Then x times 8x is 8x squared. All right. And then x times 12 is 12x. Then you have to do the negative one times each of these. So that becomes negative 6x squared.
Uh-huh.
And then negative 8x minus 12. There's typically an overlap of two terms here.
Yeah. 2x squared and 4x.
Yes. All right. If we had time, we would definitely do more of these, but I'm sure there's more you want to get done. So that's the first part. We still have to divide all of this by 2. Okay. So like sometimes you get so deep into one part of the problem, you forget like, oh yeah, I got to divide by 2. So the area of x is this equation, but then you divide everything by 2. So it's not a choice. Each of them get divided by 2.
And that one stays negative 12.
Sorry. 6.
Okay.
All right. Maybe back to some fast ones. We'll see. Nope. More products. You got all the ones with products. This one's not as long for 15. They guess they're cutting you a break. So you're going to take this 4x and multiply it by each of these. There is nothing to combine this time. That only happens when you have a more than one thing on the outside.
Let me just try it real quick.
Yeah.
Okay. So I got 4x cubed plus 8x squared plus negative 36x.
Good. Good. Like it.
Okay.
All right. So not as bad when you've got just one term. In the previous problems, you just had 2 terms and then you had to combine them. All right, so number 16 here, write an equation of the line in slope-intercept form. The slope is 2 and the y-intercept is -1. Slope-intercept is y equals mx plus b.
Mhm.
M is 2, b is -1. So
Right.
very, very fast. Sometimes you get a quick one there. All right, 17, also kind of a short problem here.
What's the degree? So it's just the degree of only the largest one.
You add the exponents in the case when there's more than one. Like this one's not written well, but it's really x to the 7th.
Mhm.
And you add the exponents. This one, so this is 7. The 1 plus 1 is 2 for the exponents. And the last one is 2 plus 3, which is 5.
Mhm.
So, sorry, the degree is the largest one.
Right. Oh, okay.
But if there's another term like, 2xy to the 19th, this would be larger because they add up to 20. But, okay, baseball, box and whisker plot. All right.
This one looks interesting.
Yeah, are you a boss? Are you following the pitch clock in baseball?
I like baseball, but yeah.
Yeah, the pitch clocks. It's
I like the
see.
plot.
Okay, so box and whisker plot. The way to do this is to order everything from smallest to largest. So just letting you know, this is going to take a while. We could skip this one unless you say we've got to do it to maximize the 20.
Yeah, we could skip it.
Okay. 19 is a little bit better.
Hmm.
All right, the cost of a chain is directly proportional to its length. Use the graph to estimate the cost of a chain that is 18 inches long. So they're asking you to sort of speculate, like, where is 18? 18, I guess maybe is there. This blue line keeps extending. And so you would go up and hit it. You'd say, okay, let me go up and hit it. And then where does it kind of bounce over to?
Uh-huh.
And you want to read that value. So I would say maybe 80.
Yeah, and the other value is 18 or what?
Yeah. Yeah. 18 inches long.
Right.
I think that's it. I don't think there's much more that's asking for.
Yeah. Okay.
20, which point represents the same direct variation as 3, 3, 9. The way to do this is to recall what it means to have direct variation. Direct variation is y equals kx, and k is equal to y divided by x. And y is -9, k is 3, that's -3. So they're asking which ordered pair has a y value over an x value that's equal to -3.
Uh-huh. Should we?
So you're just looking at each of these, like what is -8 over 4? What is -7 over 4? What is -12 over 4? -16 over 4? Are any of these equal to -3?
Yeah.
Yes,
Right. Or
this
wait.
one. This
Oh,
one's
yeah.
-3.
Okay.
Do you want us to go back? We got some more time here to go back to number 18.
Or we do that. It's up to you, but there's also 21, which isn't in the picture, but it's just to find the least common multiple of 16c to the 6 and 24c to the or c cubed.
Like this.
Yeah.
And you're saying the least common multiple?
Yeah.
Okay. To do the least common multiple, you build a factor ladder of each, and we'll get to the variables. So 2 and 8, 2 and 4, 2 and 2, 2 and 1. And then you do the same thing for 24, 2 and 12, 6, 3 and 1. And then you just start with the smallest one. So the smallest one is 2 times 2 times 2 times 2. That takes care of the 16, these numbers on the outside. You go to the next one and you see if everything is there, and if it's not there, you add it. So do you have a 2? Yeah, you got a 2. Another 2? Yes. Third 2? Yes. But you don't have a 3, so you include that down here.
Right.
This ends up equaling 48. And you might think, well, could I have figured that out? Probably, but this is the direct way. You always get it if you do it this way. So that's the number. When you look for the variables, you just pick the highest exponent.
Mhm.
The GCF is going the other direction,
Mhm.
where you pick the smaller exponent, you look for the fewest things that go into both. Something like that.
Yeah.
All right. Does that get you to your 20 on that?
Yeah, it does. So.
Okay. Really good. Got a couple minutes left. Is there anything else you'd like to do today? Anything else you want to talk about?
I mean, we got a lot done. I have
you-
the end
Go
of
ahead.
term coming up soon.
Yeah. Are you guys going to get a like a chapter review, final exam review? What are you guys going to get